Let's try question 11 is on kinematics. A particle moves in a straight line so that t seconds after leaving a fixed point O, its velocity v is given by this equation, v equals to 36 over t minus 3 whole thing square minus 9. So 11i asks us to find the initial acceleration of the particle. So note the word initial. So when we are talking about initial, it means that we need to start t equals to 0. But before that, we need to find what is the acceleration first. So we know that dv dt is our acceleration, right? So we have v equals to 36 over t minus 3 whole thing square minus 9. So this is actually equals to, I'm going to just move the denominator up, which is t minus 3 whole thing square, whole thing to the power of minus 2 minus 9. Okay, so now we're going to differentiate this expression instead. dv dt equals to 36 minus 2t minus 3 minus 3. Okay, so this gives us minus 72 over t minus 3 cubed. Okay, I'm going to move it down now. For the t minus 3 whole thing to the power of minus 3, I'm going to move it down. So it becomes t minus 3 whole thing to the power of 3 in the denominator. So dv dt is actually my acceleration. So in order to find the initial acceleration, we substitute t equals to 0 into dv dt. We get that the initial acceleration equals to minus 72 over 0 minus 3 whole thing cubed. In this case, is actually 8 over 3 meter per second squared. Okay, so we are done with 11i. So let's move on to 11ii. Find the value of t when the particle is at instantaneous rest. So at instantaneous rest, okay, v is equals to 0. So what we do is we are going to equate 36 over t minus 3 bracket whole thing square minus 9 equals to 0. Then we can have to solve this equation to find t when it is instantaneously at rest. So t equals to 5 or t equals to 1. So at t equals to 5 seconds or t equals to 1 second, it will be instantaneously at rest. And we are done with 11 part 2. So let's move on to 11 part 3. So find the total distance traveled by the particle in the first 2 seconds. Now for this type of question, right, especially when you are asked to find the total distance, okay, please try to draw a rough sketch on how the particle is moving. So at t equals to 0, okay, is actually moving here, okay, and then there's a turning point. So here is t equals to 1, because that's what we found earlier. When the particle is instantaneously at rest, it means that the particle has changed direction and it has a turning point. Okay, and then we have to find from t equals to 1 to t equals to 2, because the question asks us to find the total distance traveled in the first 2 seconds. We also understand that there's another turning point, but since that turning point is t equals to 5, which is after 2 seconds, so then there's no need for us to care about t equals to 5. Okay, so what we're going to do here is we have to find s, that is the displacement. So in order to find s, we need to integrate the equation of v with respect to t. So this is equals to the integral of v okay, so this is actually equals to let's move the denominator up. So this is equals to 36 t minus 3 minus 2 plus 1 minus 2 plus 1 minus 9t plus c. So s is actually equals to minus 36 over t minus 3 minus 9t plus c. Correct? So when t equals to 0, when the particle just started, at the start the displacement must be 0. So 0, substituting it inside here, 0 equals to minus 36 over 0 minus 3 minus 9 times 0 plus c. So this means that c is actually equals to minus 12. So we get that the displacement equation is minus 36 over t minus 3 minus 9t minus 12. Okay, so based on this displacement equation, and we know that this is how the particle moves. So from t equals to 0 to t equals to 1, okay, so it is essential for you to sketch this diagram out because it's very important for you to know where's the turning point so that you can break down the values of t and then substitute the values of t into s and then combine the total distance that is traveled and then add them up to get the answer. So from t equals to 0 to t equals to 1, right? We sub t equals to 1. We get that s equals to minus 36 over 1 minus 3 minus 9 times 1 minus 12. So this is equals to 12 minus 9 minus 12. In that case, let's see. Sorry, this is my bad. This is minus 18. Yeah, is that right? No, sorry, this is 18. Yeah, so 18 minus 12 minus 9 is actually minus 3 meters. So the displacement is minus 3 meters. So actually in this direction, moving in this direction is the negative displacement, which means that this direction is the positive displacement. Okay, so next we are going to find from from t equals to 0 to t equals to 1, right? We sub t equals to 1. So we know the displacement is actually minus 3 meters. So now we're going to sub t equals to 2. We get that s equals to minus 36 over 2 minus 3 minus 9 times 2 minus 12. So this is equals to 36 minus 18 minus 12. So this is equals to 6 meters. So the displacement is 6 meters. So actually, so this is the starting point, right? Correct? So this distance over here, remember, displacement is always measured relative to the origin. So this displacement here is minus 3 meters, right? Because it's going to the left, okay? And we have found that at t equals to 2, right, it is 6 meters, positive 6 meters away from the origin. So which means that here at t equals to 2, okay, let's say here is at t equals to 2. It is actually 6 meters away from the origin. So actually then the distance is actually, let's write it in rate. So the distance is different from displacement. Remember, displacement can be negative, it can be positive, it can be 0. So for distance, right, we just simply remember distance can be 0 meter, it can be positive, but distance cannot be negative. So what we're going to do is, just from this sketch, we're going to add 6 meter here, okay, plus the 3 meter here, and then plus the 3 meters here. So this means that the total distance is actually 6 meter plus 3 meter plus 3 meters equals to 12 meters. Okay? So that is how it is done. 6 meters plus 3 meters plus 3 meters. And the total distance traveled in the first 2 seconds is equals to 12 meters. And we are done with this question on kinematics.